Yo, yo. Yo, what's up? Okay guys, I'm going to take off these eclipse glasses. I'm doing this the day of the actual eclipse. Okay, and Mr. Atwood was kind enough to give all the teachers these eclipse glasses, which was really cool. Okay, so here we're looking at chapter 3. We're going to look at section C and section D, because section D is so short. Okay, so in the first two parts of the chapter, we talked about measurement, accuracy, precision, units of measurement, why we have those. We talked about significant digits. And now we're looking at mathematics and measurements. Rules for adding and subtracting measured data. So our first rule here, measured data has to be the same kind of dimension and have the same units before they can be added or subtracted. So in other words, we can't add 1.2 seconds and 2.3 minutes. This isn't going to work. It's like adding dollars and pennies. It's not going to work. They have to be the same unit. 1.2 minutes plus 2.3 minutes. That is the right idea for it. Okay? So the second rule of math, the sum or difference of measured data cannot have greater precision than the least precise quantity in the sum or difference. Okay, in other words, when we talk about precision, we're talking about how many decimal places are we looking at. If I'm measuring stuff and I have two instruments, one only goes to 1 decimal place, the other goes to 5 decimal places, then really when I do the adding and subtracting and all that, I have to go with the smallest precision. So in this case here, I got 2.008 grams plus 12.00 grams. Now, if we add them up, it's all 14.008 grams. Okay, that's nice. But because of our precision that we have, our least precise, okay, that's where we look at 14.01 grams as opposed to 14.008, because we need to base that off of our least precise measurement. Why? Because if we don't do that, then we could be called on saying, hey, you're being dishonest about the whole thing. Multiplying and dividing measured data. So product or quotient, okay, of measured data cannot have more significant figures or digits than the quantity with the fewest significant digits. What are they talking about? Well, if we look at this here, what is the area of a piece of paper that measures 12.5 centimeters long by 6.5 centimeters wide? Well, we already know the formula. That's not the point. The point is, when we look at this, we understand, yes, we multiply it out. That's what you should do. But when you're finishing your final answer here, we have to go with, hey, it's the smallest number of significant figures or significant digits. It's 2, not 3. So when we go 81.25, we need to take those math rules of rounding and just say, okay, it's 81 square centimeters. We're trying to keep the precision and accuracy there, but remember, in any measurement, there's always going to be uncertainty. Math rule number 4, so the product or a quotient of a measurement and a counted number. Well, wait, what do you mean by a counted number? Well, let's say I was measuring something, I weighed, 4 marbles, they all happen to be the exact same mass, and so my counted number is 4 times the mass of my marble, of each marble, and I got 17.68 grams. So the product or quotient of a measurement and a counted number, that's our counted number here. Conversion factor or defined value has the same number of decimal places or the same precision as the original measurement. So when we're looking at this, we're going to look at how far does the precision go. In this case here, it goes to 2 decimal places. So we're going to take it 4 times 4.47 is equal to 17.668. So we're going to look at 24.0 milliliters divided by 8 equals 3.0 milliliters. Now, notice we're not talking about how many significant digits here. We're not, because it's a division or a multiplication problem. We got to look and see how precise the precision. In other words, how many decimal places are we looking at? That's what we're talking about, precision here. How many decimal places are we looking? So here we have 2 decimal places, right? So our answer is going to have 2 decimal places. Here we have 1 decimal place. So for our precision, it's 1 decimal place, and that's it. So what about compound calculations? Well, what do we mean by compound calculations? Well, maybe I have to sit there and I have to multiply and divide, and then multiply by something else, divide by something else. That's what they mean by compound calculations. In other words, you're working through multiple steps to come up with some kind of an answer. So math rule 5, in compound calculations, you do not round off at the intermediate steps. In other words, you wait until the end. Keep calm and wait until the end to round off the number. That's a pretty important thing. Now this, ladies and gentlemen, we are done with section C. How do we go? The basic rules for solving math problems. Now, orderly problem solving, chapter 3D. Here we go. We look at the steps about solving a problem here. And the first thing is we need to read the statement of the problem. Now keep in mind, this is a life skill. This is not just applying to chem, and it's not applying to math. This is a question of applying to things that will happen in your life. Do I marry this person or not? Do I have enough money to afford renting this apartment, or do I need to get a roommate? Do I have enough money to pay for my college books and be able to take my girlfriend out on Friday night to Glendora AMC? See, that's where problem solving comes in. So you read the statement of the problem, you determine the method of the solution, you choose the specific tools to use, set up the problem, estimate and calculate, and then you check and format. So that's pretty much the basic thing here. You'd say, but wait a minute. To choose the specific tools to use, how does that relate to my date with my girlfriend and balancing, if I can afford enough textbooks? Think about it. You have to use math in order to be able to afford that situation. Can I afford to do that? Given that I am making X number of dollars an hour working as chief French fry fryer at McDonald's in Laverne on a Saturday night. So this applies. The concepts, the ideas also apply to real life as well. Rounding off, our last thing, we got to talk about density. Because you know what? It is a ratio of the mass of a substance compared to its volume. So in other words, the larger the density, the more dense it is. And it's going to feel heavier. The lower the density, the lighter it's going to feel because it's not going to weigh much. So density is equal to, and I notice the picture of the heart here, you got the arrow right through the line through the middle. It's mass divided by volume. High density, the particles are pretty much packed together. Okay, high density, you can think about metal. You can think about metals like iron, gold, silver, aluminum. Low density, the particles are not so, they're loosely packed together. They could float like wood. How about styrofoam? That's another one. Very low density. Balsa wood, if you've ever worked with that. So here on this picture, we've got different densities of different things. We got honey, corn syrup, dish soap, water with some food coloring, and vegetable oil. And if you notice, they form 1, 2, 3, 4, 5 distinct layers in the cup. Well, what's going on? The stuff that's more dense is going to sink to the bottom first. Why? Because it's heavier. Okay? So like foam, diamond, and iron, look at the difference for 1 little cubic centimeter. So I mean, like, think about like this. Okay, that's like 1 cubic centimeter. 0.03 grams of foam. For a diamond, it's 3.5 grams, so it definitely weighs more. And in iron, it's going to be 7.8. Yeah. So there's definitely a difference in density. water does have its own density as well, and we're going to be checking that out in the lab. Unless you're watching this as a review for a test or final or whatever, okay, but we are going to be doing that in the lab. It'll be one of our first labs that we'll do. All right, hey, I hope this benefited you guys. Peace.